Okay, we need to wait for some time until most of you have come back. Now, for the time being, it seems most 4A students have come back. So I would like to check I would like to check the presence first of all. Let me see. All right, so today's is day 5. All right, so Trần Hữu Thành, are you here?
Yes, I'm here.
Okay, Trần Ngọc Ca,
Yes, here.
Tăng Gia Kiệt, Tăng Gia Kiệt, Tăng Gia Kiệt, are you here? Tăng Gia Kiệt, I cannot hear you. Oh, you just come here, right? Tăng Gia Kiệt, Hoài Lâm.
喺度。
And wait, next is Lâm俊Hiên,
喺度。
林靜漢，林靜漢，
喺度。
李佩恒，
喺度。
鄧俊熙，
喺度。
鄧浩俊，
你好。
黃俊熙，黃俊熙，黃奕朗，黃奕朗係 here。鄭學明，
喺度。
張思維
Hello。
，OK，係馮家軒，
Hello。
韓孝日，韓孝日
Hello。
係何麗妍，何麗妍，何麗妍係 here。
喂，
係黃奕朗嚟嘅呢個。
係。
何麗妍冇，郭俊熙
Hello。
係，羅康力
Hi。
係，李晴，
Hi。
梁家傑，
喺度。
李澤星
Hello。
係，李健樂，
喺度。
馬家樂，
Hello。
吳漢一
Hello。
係，魏俊滔，譚君佑，
喺度。
黃成軒，
喺度。
OK，何麗妍 no mic but you will be here. So Just double check 黃俊熙。
天傻喺度，頭先聽唔到。
Okay, now, so we will start the lesson very soon. And last time I asked you to do the class practice, right? On just behind the, just at the back of the. Let me see which page. I've told you guys to do page 150. Page 150, class practice 9.1. Okay, have you all done that? I'll repeat, page 150, class practice 9.1. Do you find this page? Now I'll give you some time to take a look and find this, and we would have a recap and try to understand more about the giant Ionic structure, and its property. Okay, do you find it? So for the first question, they are asked about to draw the electron diagram of cesium iodide, showing electrons in the outermost shell. Maybe I need to turn on the screen. I would like to share the screen first of all. This one, okay. So page, this one, okay. Do you see this? It is on page 150. Class practice 9.1. Shall I invite some students to have a anyone who have got a pen? Going along, do you have any pen?
I can't.
Now,
Oh.
if you're asked to draw the electron diagram cesium iodide, what do you have?
Cesium ion 同呢個 iodide ion 咯。
Yeah, electron diagram. So what is that?
Yes.
How do you draw?
Electron diagram.
So what is that?
Just draw 咯。
So what is that? So we have got a bracket, right?
Yes.
Middle bracket of cesium.
Yeah.
Okay.
And
so symbol of cesium is
CS.
yes, capital C, small letter S again. What is the charge?
1 plus.
1 plus. Okay, plus 1. So you just mark it as 1 plus and then
Yeah.
iodide. You may see it as iodide. I.
And 8 electrons.
8 electrons. So how will you show the 8 electrons?
All
with
around.
Around 1, 2, 3, 4, 5, 6, 7, 8 like this.
Yes.
Okay. What do the others think? Now, how would you show it? Or some electrons they are from cesium atom. Okay, you need to mark a cross. Okay.
Okay, X.
Yeah, mark a cross here. Just one cross. Okay, one cross. So that cross is very important. It tells you this is from somewhere. It's not from iodine. Can you get my point? So you may use this to distinguish one from another. So cesium iodide is this. So don't worry about the inner shell, right? Those electrons, because as said in the questions, you are going to show the electrons in the whole shell only. This A part. Okay, you get the point. So what you need to know is to memorize that two symbols. And at the electrolysis experiment, you can perform using an aqueous solution of cesium iodide to provide the evidence for the presence of ionic bond. Draw a label diagram of the setup that can be used for this experiment. Label diagram. So what can it be? Any diagram which is very similar to this in the book. You may try to take reference to it. So what can it be? Lâm Danh Hon. Lam are you here? Lam not here. Okay, Lam not here. Can I have a yes? Laser send good. Page 79. Now you refer to it. What is that about? 79. So 79, we have got a diagram like this. Yes, very good. We have got a crucible. Okay, you are writing the draw label diagram. You are going to draw a crucible, and then with the solution. The solution is cesium iodide aqueous solution. Can you see that aqueous solution? So you may write down in English, but also you may write down in symbol. How would you write down in symbol? How would you write? It is just SCSI and with the symbol AQ. Can you get my point? Now you may see that a very small letter AQ bracket, which symbolizes as aqueous medium. Okay, so very similar aqueous solution, and you are going to show it as AQ. Okay, can you get my point? And what's next is to put the light bulb, okay, and connect it into power supply. So you may use the battery for help, or maybe you may just use two dots and then tell me one is plus, one is minus, and remember to write it down as DC supply. Do anyone who know what is mean by DC? What is DC? Anyone who know it? Tan Junhei, do you know what is mean by DC supply? What's mean by DC?
Dry cell.
Dry cell.
know.
Dry cell. DC. So the another term of power supply is called AC. AC and DC is different. Okay, if it's something about physics.
Yes.
Yep. What is mean by DC? DC power supply. You see the word DC. Well, so what is that?
Direct current.
Yep. Good. So AC means something else. So what is mean by AC? AC, what is that? Alternating current. So it is different. It's different in terms of telling the electrolysis. Remember, for electrolysis, what is mean by direct current? Direct current means the current will flow in one direction only. Okay, so in this case, if I put it as the battery dry cell like this, so what is the electron flow? What's the electron flow? This is plus 長定短負, right? So you may know the electrons will flow through in this direction, okay? Electrons. Can you get my point? So current is in the opposite way, while this direction will not change unless you change the polarity of the battery. Can you get my point? So how about alternating current? The direction of those electrons, in which you say it in physics term is current, will change. So that means we call that alternating. So in Chinese we call it 直流電交流電. Can you get my point? So alternating means in terms of direction, there will be a change in direction of currents. Okay? Can you get my point? Do you understand? I found that somebody say my mic is not so clear. Is it better?
唔係咪你講嘢少細聲？我聽到都有啲細聲。
Yeah, a little bit soft because I'm now in the staff room, so I don't want to make my voice too loud to disturb the other colleagues. So that's can you hear?
Yes, can hear. Actually,
Okay.
if you don't have enough sound, you can up
Or
make
just
your
turn
volume
on.
higher.
Yep. Just turn on the volume. Try to see if you can really not cannot manage. You may let me know. So this is what you may write down as a labeled diagram. So what are those two rods? Do you know what are the two rods? We call that electrode being gap. So normally it is made up of one material. Okay. So what is that? What is that material? Can you please give me some suggestions for that?
Carbon.
Carbon, yes. Carbon in terms of graphite. Okay, graphite, Cesium. So the one which will conduct electricity. Okay, we call that carbon rod, and use it as the electrode. It is made up of graphite, Cesium, a black substance. Okay, and it is a conductor. Suggest how the results can show that the bonding is ionic. Suggest how the results. So what results here will show you the bonding is ionic. There are some indication, right, to tell you there is a flow of
They separate.
there's a flow of what? The flow of charge, right? The light bulb. Okay, the light bulb will happen. The light bulb lights up. Okay, so this is one way to tell you that there is a charge flow. Okay, there's a charge flow. So you will tell indirectly that I just shaded this part. There are some charged particles. They are moving in a directional way. Okay, can you get my point? So lastly, it's about discuss with explanation. The electrical conductivity of cesium chloride with reference to the type of particle of bonding in it. So you remember, you are going to tell clearly, right, about two different states. Okay. So what can it be? Chang.
Yes.
Yep. What do you think? Can you elaborate on this for explanation?
It means the okay.
Yes.
So as cesium iodide is an ionic compound,
Mm-hmm.
and an ionic compound conduct electricity in molten in aqueous solution, but not in solid state.
Mm-hmm.
And in the experiments, the cesium iodide is in aqueous solution and it's conduct electricity, and it decomposes to form cesium atom and iodide. Oh,
Mm-hmm. Mm-hmm.
and so that's all.
Now, you mentioned cesium iodide in aqueous form, in aqueous solution that conduct electricity. What is the reason? What is the reason?
You mean
Yes, what is the
cesium iodide is ionic compound?
This ionic compound, so it conducts electricity. How about the others? Now said there may be some key items that you need to address. This is the reference to the type and property of particles in it. Okay, so can you see the word type and the properties of particles in it? Yep, I can hear some voice.
When cesium iodide is in aqueous solution, the particles, there is mobile ions,
Mm-hmm.
and it can move freely to conduct electricity.
Okay, so the ions become mobile. While because of this, the word mobile ions, they would move around. Okay, They can move around. They in the solution. So and thus, what will we call it as conduct electricity? Okay. So that type of the saying electrical conductivity, it seems to be conditional, right? Conditional means at certain state it will conduct electricity. Okay. Is it only just aqueous solution that conduct electricity? We've got another situation.
Molten.
State.
Molten state. Okay, so you have to mention it as well. In aqueous solution or in molten state, the ions, they will become mobile and move around in the solution or in the molten salt and thus conduct electricity. Can you get my point? So you just say it's conditional, right? How about solid state? How about solid state?
When cesium iodide is in solid state, their ions are not free to move.
Yep.
They are not mobile.
Yes, good. Doesn't conduct electricity. Tell me first of all, and why it is not in solid state? It's because the ions, they are held in a fixed position, okay, and are not free to move. Okay, can you get my point? So this is it is more complete to tell you the electrical conductivity. So remember, this word in Chinese, we call it 導電性. So it doesn't tell only the situation when it conducts electricity, but you have to tell also the situation where it does not conduct electricity. So especially for the case of ionic compound. So you have to state it clearly what under what situation will need not conduct electricity, first point, and give me reason. Okay, so in order to make the whole answer complete. Can you get my point? Now, so this is what I would like to talk to you about one of the very common common type questions in it. Okay. Now, you may find some similar questions, right, as reflected into your assignment. Okay. Do you know that you have got an assignment? When is the deadline?
This Friday.
Friday.
Yep, this Friday. Could you please refer to it? So you may find ionic compound chapter exercise. I posted on 14th of September. So you may see some questions. Okay, for the chapter exercise, here comes MEMC 2 and 3. Now you may do part of them together, right? Part of them together. So MC. Now question 2 and 3, you may do it now, okay? And question 2, which shows the giant ionic structure of sodium chloride. Is easy, right? Easy as that. Which one? Which one seems to be a better example?
D.
A, B, C, D?
D.
D. Agree?
Yes, agree.
Yep. It's D. Okay. It's D, but not C. Why is it? But Mr. Chin, for this one, it is quite different from what you see in the textbook. Okay, in the textbook, it's not just that 8 particles at the corner. You may see on the edge, on the face, right? Is it similar? How is it similar to when you find it on the book before? This one.
This is only one of the block, like.
Yep. It's just 1/8. Okay, 1/8 of the block of the unit. Can you see that? It's just 1/8 of the unit. How do you know that it's 1/8? Now you refer to the previous page to tell you this one. Okay, we've got sodium chloride. Can you see? Now it's just 1/8. Just one name. So we have got the structure like this. If you don't know anything about this, don't worry. As long as you check what? You check the arrangement of ions. Okay, you check the arrangement of ions which is placed in an alternative manner. Okay, opposite charge ions, they are placed in alternative manner. So you may see that sodium ion, chloride ion, sodium ion, chloride ion. Do you see that? They try to put it one by one. So the answer is D. How about question 3? Which of the following compound is a giant has a giant ion structure? Now remember, I will use the word hex, a giant ion structure. Question 3. A very strange example, right?
Boy.
Is boy correct? Somebody say boy.
I think it is D.
Somebody will think it is D. Okay, it's D. So how many of you think that this is boy? You please put a tick. A D, you put a cross to tell. Very strange, right? Strange way of having a book here. So I will see 1 person, 2 person choosing B, 7, 8 now. 8 choosing D. Dot 10 now. So what will be the answer? Giant ion structure, what substances? That compound should be ionic compound, right? Only by having ionic compound, it will form ionic lattice, while the structure, we call it as giant ionic structure. So you may see what you're going to do is to spot the ions. How about B and D? Do you have any ions here? So for D ions, they are ammonium ions and nitrate ions. Okay. No metal ions, right? But we have got ammonium ions, which is the cat ions. How about A, B, and C? Now A and C, they are arranged differently. So we cannot split it and tell me something plus something minus. So A and D are not the choice. How about B? B, it is the compound itself is not a giant ion structure, but maybe some of you may heard it before, right? So what is that? It is nitric acid. Nitric acid. So that one, it is very special. It is a type of molecule, but that molecule is very strange. Once I dissolve in water, that nitric acid molecules will give out ions. Okay, will give out ions. So because of that, and process is acidic property. Okay, so I circle the one, it will show you some acidic property. So what is meant by acidic property? For example, when I use the pH paper to dip into this substance, right? Or maybe I would have limestone, you know, in calcium carbonate, right? So I dip that nitric acid solution, is acid, right? And then there is some colorless gas bubbles. So so go back to this question. B is a very strange example. Can you get my point? So it would have ions, but it is conditional. Okay, only when what? Only when it is dissolved in water. Can you get my point? Only by dissolving water, the HNO3 molecules will form H ions and nitrate ions. But for D part, irrespective of the state, whether or not it is solid, molten, or in aqueous solutions, you still have ammonium ions and nitrate ions. So the answer is D, not B. Any questions? Any question? So do you mean that, Mr. Chin, for acid molecule, right, just like HCl, okay, it is also a molecule. So would it form ions in aqueous solution? The answer is yes. Okay, also yes, very similar. So what ions will be formed? What ions will be formed? Can you guess? When you're long, can you guess what ions will be formed? Yeah, what is that? A very strange process. We call that ionization. So ionize means I turn something non-ionic to ionic. So the product is hydrogen ion and chloride ion. Okay, how about sulfuric acid? Cyrus?
Yes.
Yes, if I have sulfuric acid molecule, once I put it into water, it will ionize, right? So what can the ions be?
Hydrogen ions and sulfate ions.
Good. Hydrogen ions and sulfate ions. Of course, you may think of, can I have hydrogen sulfate? Yes, you may have. You may have also have a chance of hydrogen sulfate. Okay, it depends on the situation at that time. Okay, do you understand? So remember, for acid, it's a very strange example. If I put it in aqueous solution only, remember, only aqueous solution, it will form ions. But in molten state, no. But at their normal state, molecular form, no. Except before it's a molecule. Okay. Any questions? Any questions? Now I would like to show you one more example before we come to the next structure. It is on question 25. This one. This is another example. You may find that it is in ESE past paper 2013. Okay, that means in Form 6, right? Form 6 will have got a public exam. That questions will be of that similar level. Both cesium and sodium, they are elements in group 1 in the periodic table. Cesium reacts with chlorine to form cesium chloride. Solid cesium chloride is a giant Ionic structure. Draw a diagram to show the structure of cesium chloride. Oh God. Of course, you may think that Mr. Chin, I can locate a page to tell you. But in reality, you have to show your drawing. Oh God. What is that drawing be? Can you find something challenging now? You are going to draw the structure. How? Can you locate the page for me first of all? Which page? Tang Hu Zhen. If you're asked to draw a diagram of cesium chloride, so what is it? Tang Hu Zhen.
Yes.
Yep. A1. A1. What is that? Previous page again, right? So you may find the page 144. So you may have, yes, this is the structure. So in the exam, you may not be so able to, now I need to tell you the reality, okay? In your written exam, while in the internal exam, I may recognize the color to tell which ion is which. But in your public exam, all those words will be scanned in black and white. So you have to learn how to express differently the ions of it. Because why do I say so this time? Because cesium ion and chloride ion, they are very similar in size. So it is quite difficult for us to take a look and imagine it as in black and white. How would you distinguish? Now, first of all, I draw a dotted cube. Okay, and what's next? Can you give any example to distinguish how you are drawing cesium ions and chloride ions respectively? How?
一個中心，一個實心。
Oh, yeah. The one is solid or the hollow, right? Good. This one way. So you have to think it by yourself. Okay, for example, this. Okay, this represents what? We have got this, that will represent what? You are going to tell it clearly. Okay, for example, like this. So can you tell what is that? If I take back the one in the book, you may write down a cesium ion here and chloride ion here. How about in reverse? If I change it, if I exchange it, is it also okay? Is it also okay? The answer is yes.
Sure.
Yep. Why?
Because they are 即係 same 咯，一樣都係一粒對8粒咯。
Okay, they are in 1-to-1 ratio and the coordination number. So what is mean by 一對8? So we call that coordination number. The coordination number means the number of ions surrounding the other of opposite charge. Okay, so also it is 8. And also the size, they are more or less the same. So that solid ball and the hollow ball can be interchanged. The role of it is interchange. No matter what way you are going to express, remember to keep me to put this caption here to let me know what you are drawing instead of just pointing the arrow 1, 2, 3, 4, 5, 6, 7, 8. What is that? Okay, it's very, very messy. So you use caption and it will help. Do you understand? Please use caption. Okay, any questions? Any questions? Okay, no. It's more challenging. It's on B part. On B part. Explain why solid cesium chloride is brittle. Explain why cesium chloride is brittle. How? Why?
It is formed by positively charged ion.
Mm-hmm.
And when an external force applied to it, the same move. I can use the word move.
Mm-hmm.
They move, and their position change, and there is repulsion with, among the same charged ion.
Okay, I can see some keywords. First of all, tell me the structure. So it's time to write down the template here. Okay, the template it is just it's just like a form of paragraph that you need to answer. So that we have got a template to tell it is brittle. Every time when you try to account for the difference between the property of a substance. Okay, we've got a property of substance which is related to what? To its bonding and structure. So can you get my point? So this is the arrow that I showed you last time. Okay, remember, that means you are going to account for the reasons why solid cesium chloride is brittle. You are going to stick back to this framework. So if first of all, if I'm going to talk about this one, bonding and structure of cesium chloride. So what should I write? Cesium chloride has a what structure? Giant ionic structure. How about bonding? You did not tell anything about bonding. With ions, okay, held by what? Ionic bond. Okay. Or you say that ions of opposite charge. Why do I say opposite charge? Because I need to prepare to tell something about the property. The property, what can it be? It can be melting point, boiling point. Okay. Yep. melting point, boiling point, brittle, hardness, etc. Right? So this is the example. So after telling this point one, here comes point two. You are going to relate to the property of the substance. Okay, can you get my point? So how would you express it as brittle? You need to do something. What should I do? To test it as brittle, I need to what? Apply a force.
Force.
Okay, yeah. So remember to write down when a force is applied on the substance. So we try to bring the people from the scope from macroscopic to submicroscopic. So you are going to talk about particle viewpoint, something very, very small. So we will have layers of ions. What will happen? They will slip over, okay, each other. Okay, ions. What will happen? There will be a chance of having ions of the same charge. They will come together and then repel. Okay, and causing the substance to split apart. Can you get my point? So we will say it as cesium chloride is brittle. So you may find this type of explanation being a little bit long. How can we express it fully? You may think of some way. First of all, memorizing the whole thing. You may find it quite hard, right? But you are going to think of another way.
Memorize the template.
Yep, memorize the template is one way. What else? Have you ever heard of some diagram? The diagram may help. Okay, the diagram. So the diagram, what all those are talking about is just the diagram like this. Okay, you may think of this diagram. So minus plus minus plus. Can you get my point? Plus minus plus minus minus plus minus plus plus minus plus minus, and then you do something, a force, and then what will be the next action? I do the same thing, right? Okay, and I focus on this part, and we have got plus plus, okay, and minus minus and plus plus. Can you get my point? And then I use this diagram to tell you they will split apart. Now once you use this diagram and you put this in mind and try to check against those green description. Are you talking about something similar? Can you get my point? Are you just have to move these block of particles towards a little bit in the direction, and they will course another direction like this. Okay, and they will have a chance of having repulsion of the ions of the same charge. Can you get my point? So we will call it as a template. So just repeat what the template is about. First of all, tell me the bonding structure of the substance that it has. Second, try to bring the people focus to tell or to explain something about its property. This time I use brittle. So remember, brittle you have to pass it is described because of having a test, right? The test of being pressed, okay, hardness test. So I apply a force into it, and then finally the block splits apart. It is something macroscopic. How you express it microscopic? It is something microscopic, or we call it submicroscopic, right? It is this, right? Can you get my point? I will say it once again in Chinese. 你要解釋一個嘅 物質啊嘅特性，我哋要用佢哋嗰嘅佢哋之間個結構啦，同埋個吸引力，咁你要去解釋嘅。咁第一句咧一定要解晒佢嗰個嘅結構噶啦。跟住就做咩咧？就將群眾咧個目光咧就由一個宏觀嘅角度，請將你宏觀角度，宏觀嘅角度就係 brittle 啦 ，brittle 就係脆啦嘅咁我哋用一個微觀嘅角度去解釋。Okay, so that's why you may see something that we cannot is invisible, just like ions. Can you see that? Same charge. Right? All those wordings they will tell you, they will bring you to something very very small scale. While brittle is something in a large scale that you can see, but ions you cannot see. Can you get my point? For those who can get what I mean, please put the thumbs up, right? If not, down. Let me know. Yep. Nice. Somebody, quite a number of you can understand what is that. Good. Good. Do you think that you can manage to do the other 3 questions, right, for the Friday assignment?
Okay.
Do you mean that the thumbs up means all those can finish? If so, I will not further explain. Yeah, maybe some of you may think that Mr. Shin, is it just referring to the book? Now, some questions it is, yeah, okay. But you are going to use your minimum method to focus on the questions, read the template, and try to use this template to continue your work. Okay, what I mean is using bonding and structure to relate to the property of the substance. Any questions? Any questions? Now, I would like to draw attention to the other 5 long questions. I briefly tell you what to answer, okay? Such that you would not, you will have an easier life this time. Because it's a very first homework about bonding structure. So now go back to here. Now, what is meant by topic exercise, right? Topic exercise is something behind, right? It tells all chapters mixed together and do the exercise. So you are going to relate to 27. Take a look. This question, this is the first question. Lithium. Can you see that? Lithium occurs naturally in 2 isotopes. Lithium 6, lithium 7 is a form of nitride. We're very near. Calculate percentage abundance of this. Wow, form 3is. Okay. Draw the electron diagram of lithium nitride, showing electrons double shell only. Okay. Is it clear? It's easy, right? Easy. Hong Ka-him, do you find it easy?
I need to some time to understand it. I will repeat the video once more time.
Okay, 28. Take a look. 28. What is it? You are going to describe and explain what we expect to observe when the circuit is closed for a period of time. Cobalt to chromate. Wow. I've done that before, right? Okay. And also you have encountered this before, correct? So, Tam Guan Yao, tell me the color of cobalt to chromate. So what is the color of cobalt to chromate? Yes, it is something related to migration of ions. And in this time, the ions is colored, okay? Tam Guan Yao.
Yes.
Yep, tell me the color of cobalt to chromate. I can hear the typing sound. Search You're asking the god of Google.
Yes.
Yeah, tell me what is the color of cobalt to chromate?
Blue.
Blue. Why?
Let me find. It's dark green.
Dark green. Why?
Or green. I don't know.
You don't know. Maybe you can think of the concept of the mixing of color.
Cobalt 2 is blue and chromate is yellow.
Cobalt to iron is blue.
It's pink and yellow.
Oh,
Agree?
sorry.
Pink. Blue or pink?
Cobalt 2 is
Blue.
pink.
I think so.
Cobalt to aqueous ions is
Pink.
pink. Okay, it's pink. So
Okay.
maybe you have heard of the case about dry cobalt to chloride paper, right? Do you still remember that one?
Oh, so it becomes pink when it is aqueous.
Yep. Or you will talk about when the paper is moistened, so the color become pink. Okay. So why is it moistened? It become pink because the cobalt to iron, it is now surrounded by water. Okay. Once I have this water that surrounded it, okay, it will give it as a special color. Okay, so it is pink. Okay, how about chromate?
It's yellow in color.
Yep. So mixing pink and yellow,
And I don't know.
pink and yellow becomes big gas. Pink is similar to color red, right? Red plus yellow becomes, hey, come on.
Orange.
It's orange, right? It's a little bit orange, right? Pink plus yellow is also a little bit orange. Mr. Chin, are you teaching VA? Yes, you have. Yeah, I'm also teaching common sense. So you have to memorize it correctly. It's a mixing of color. Okay, pink plus yellow equals bad. Don't tell me anything about your your VA skills, good or bad. Okay. It's just common sense. Tell me the mixing of color is orange. So use the original color is orange, but as said before, cations is pink. Yeah, the anions, chromate is yellow. So once I put it into the gel, is a solution here under influence of electric field. So what will happen? Okay, what will happen? So the ions will migrate. It will move it directionally, one by one to either side. Okay, can you get my point? So then, you can you get what I mean? So there will be a migration of ions to two different ends. So you are going to describe the observation first of all, and then explain the observation. Remember the term describe and explain. 2 points. Describe and explain. Okay? You get a point? Yep. So you know the answer. You know it? How about Freddie?
No.
Oh no. Don't worry. You continue to say that no, and you don't know. You'll be given more learning opportunities, and you will know it in one day. Question 31. Calcium can burn in air. Calcium nitride is formed with calcium oxide. That question. Draw the electron diagram of calcium nitride showing electrons in outermost shell only. Wow. Right, you may guess, right? It's easy, right? Something use of middle bracket, something plus and something minus, something like that. So you are going to think it like this. B, in terms of charges, explain why the ratio of calcium and nitride ions is 3:2 in the lattice. You are going to think of what? Balance of charge. Do you still remember that concept? That questions you have done it before. Part C, calcium nitride reacts with water. Right, the chemical formula of calcium hydroxide is easy, right? ammonia is a gas. Ammonia is a gas at room temperature and pressure. The boiling point of this one is optional. No need to do it for the time being. Liquid ammonia has a low boiling point. Because it's not ionic compound, so no need to do this for the time being. Okay, for those you have already know the answer, is optional and you may write down. 32. 32 hydrogen reacts with sodium to form sodium hydride. The structure similar as sodium chloride. Draw the electron diagram, blah, 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 easy. Chemical easy. Diagram to show the structure of sodium hydride is also easy, right? 33. Even though you have got 3 thumbs up, it means very, very easy, okay? So magnesium reacts with oxygen to form magnesium oxide. Describe what will happen in terms of electron loss again when they combine with oxygen atom. Okay, so something formation of ionic bond, right? So the chemical formula of magnesium oxide easy. Used to this one, heat resistant brakes. State and explain the property of magnesium oxide that makes it suitable for this use. So if you want to tell the property is heat resistant brakes, so what is the property? What is the property we are going to mention?
What heat conductor?
High melting point.
High melting point. Somebody will say high melting point. Conductor. Which one? What is mean by heat resistant brakes? So what is the use? So what is the use for the furnace linings in the steel making industry? Can you get what will happen? We've got a furnace. Furnace is a place of fire, okay, of burning something inside. So for the container, you need some materials to build the container, right? The container, they will use the magnesium oxide bricks. So what property are you looking for? You say that heat resistant. Somebody say the high melting point. Is it correct? High melting point. Is it possible? Or conductor? Which one?
Conductor.
Conductor. Why? Why?
Because you use it to prevent people from being heated.
Oh, so you want to tell it is heat insulator, you mean?
Yes.
Okay, how about melting point? I heard somebody who say melting point. Who said so? Is it Cyrus? Is it
Yes.
Cyrus? Yep. Could you please elaborate more on this part? Why you would say melting point? Is it that it tells you a property?
Because the ionic bond between magnesium ions and oxide ions are strong, since magnesium ions need to give oxide ions 2 more electrons. So I think magnesium oxide has a high melting point.
Oh, high melting point. So my question is, let me put it this way. Why do you think that high melting point is a property to be mentioned to account for the bricks being heat resistant? Why will you choose this? Can you get my point? Why will you choose?
High temperature 先至耐熱啊嘛。
Yes, that's right. Yeah, 呢個耐熱咧 and if I have the bricks at a low temperature, what will happen?
Melting.
Yes, it will melt, right? So high melting point. It is one of the one of the points that you have to relate. Can you get my point? So I will give you the hint. Any questions so far? Okay, I do hope that will help you answer the questions about these 5 questions in your homework. Any questions? Now we come to something new. Huh? Yes, we come to something new. We come to something new about another structure. Okay, we have got ionic structure. I will show you another structure very similar, which is called metallic structure. Okay, metallic. So you may refer to the book page, chapter 7 again, chapter 7. So we come to another bond. We call it metallic bond. Have you ever heard of this term before? Yeah, Mr. Chin, I found this diagram quite familiar. When have I seen it before?
Form 2.
No,
Form 3, Form 3
it's
IN.
Form 3 final exam.
嚇係咩？
The bonus question. Can you see that? It is the bonus question. Of course, Form 2, maybe you have seen that before because in which chapter?
Electricity.
Yeah, because we have got something which is freely moving. It is electrons, okay? So we've got a piece of metal, magnesium. But in Form 3 final exam, in the bonus part, I try to make up the whole paragraph starting from this. Oh no. So let me put it in another way around, which means that you have heard it before, right? So a metallic bond. So first of all, what substances will have metallic bond? Mr. Chin, it seems like
Metal.
IQ questions. Yes,
Metal.
it seems like IQ questions. Yes, that's right. So remember, what material will have metallic bond? It is metal, all metals, including mercury. Mr. Chin, why will you say that mercury? Mercury is very special. It's liquid. Okay, but the attraction force that holds the particles inside mercury is also metallic bond. Okay, so the bonding found inside is a pure substance, is an element, not compound. While in ionic compound, of course, it is not an element. Can you get my point? So, what you know about metallic bond is something about Mr. Chin. The bonding refers to electrostatic attraction again. Okay, so whenever I talk about electrostatic attraction, it must have something plus and something minus. Can you locate it for me? What is plus and what is minus? What is that?
Plus is the metal ions and negative is the free electrons.
Yep, metal ions and free electrons. So in Form 4, we would describe it as that electrons, it is delocalized. Okay, a new term. Sorry, delocalized. Delocalized means they will no longer localize at a place. They will no longer at that position. They will move away. So we call that delocalized. 中文離域. So the place it is no longer there and they will go to some other places. So it symbolizes freely moving. Okay. So at this time you have to change the wording. Metal cations it is plus. Delocalized electrons is minus. So that holds it in as a metallic bond. So wait a minute, Mr. Chin. So if the ions they are freely moving, can I draw the direction of those metallic bonds? Can you show me the direction of the metallic bond this time? It will be quite difficult. Why? Because those electrons, they are freely moving. They are moving all the time. So which means that when I'm going to pinpoint which are the ionic bond, for example, these two, right? But with 1 second later, that electrons will go away, right? For example, to do this position. So the metallic bond between plus and minus will go to these. They will change minute by minute, okay? But second by second, even second by second. Okay, so that's why whenever you have got plus and minus, they will have that intrinsic attraction. So we will call that type of attraction non-directional. Okay, remember non-directional, 非方向性. which means that whenever the attraction will already there, whenever you see something positive and something negative. Okay, very strange. And very often, how about the localized electrons, the free electrons? Do you mean that all electrons will be delocalized? The answer is no. Only outermost shell, only outermost shell, that electrons in the outermost shell will be delocalized, which means that if you are talking about group 1, group 2, group 3 atoms, we have got electrons 1 to 3, okay, and in the outermost electron shells, so the outermost shell electrons per atom released will be different, okay, and how does it affect? They would affect the electrical conductivity, okay. Can you get my point, Mr. Chin? You just scared me again. Okay, what you are going to talk about? First of all, metallic bond, the definition. So memorize the definition, please, because in the DSE, it is frequently asked, right? So you have to know what is metallic bond. It's a strong electrostatic force of attraction between something plus and something minus. Remember, those outermost shell electrons has been delocalized. The ions will be stay here. So which means that if you have got magnesium, for example, we've got Mg2 plus and 2 electrons, okay, per atom. And we have got that metallic bond between them. Can you get my point? And what is so special this time is about the C of the localized electrons. Why I say that C? C symbolizes that it is quite a large amount as well as it is freely moving. It's freely moving. So with that freely moving the localized electrons, what will happen? It seems like a glue that binds the metal ions together. So we will call it as metallic bond. Okay, can you get my point? And said before, I said it is non-directional. Non-directional, okay? 非方向性. Do you have any questions for this part? Do you find it easy, difficult, or what? You understand? Now, if you understand this, I would like to show you this. Your old friend. Oh no. Mr. Chin has entered the wrong Google Classroom. It's not. This is Form 4 chemistry. I will show you this. I don't want to see that again. But take a look on this. Take a look on this. So I focus on this paragraph, okay? Study the following paragraph and answer the questions that follow. And try to revisit this question again and try to see if you can answer. The atoms in the metal, they are packed together in layers. Atoms of metals in group 1 to group 3 have 1 to 3 electrons in outermost shell. These outermost shell electrons are lost from the atoms and become free to move randomly through the metal, and they are said to be delocalized. Having lost the outermost shell electrons, the metallic atoms become positive ions, and they are held, among the positive ions, they are held in fixed position arranged in a regular way, like this. And then, what's next? The electrostatic force of attraction between the C of the localized electrons and the positive metal ions act as a glue that binds it together. So we call it metallic bond. So something more challenging here. So you better capture the picture here, or maybe I will show you that paper. Okay, the factors that affect the strength of Magpie Bond include: 1. The number of electrons delocalized from the metal. 2. The charge held by the metal ions. 3. The size of positive metal ions. Okay, Mr. Chin, that's enough. Is it similar to the accounting for the strength of ionic bond? Very similar, okay? Well, the first one, you talk about something minus. And the other two, we talk about something plus. Can you see that? Relate to the metal ions, the charge and the size. And the minus part, you tell number of electrons delocalized from the metal atom. Okay, can you get my point? So I use this. Can you relate the following? Can you relate the following? First of all, can you tell the number of outermost shell electrons per metal atom lost for delocalization? Can you write down the plus sign greater than or smaller than sign? How about the first one? Number 1. Do you still remember that one? Yep. It is this, right? We have got 3 outermost shell electrons, 2 outermost shell electrons is 1, right? So we have got this. Again, charge of positive metal ions. What's the charge? Again, okay, why? Sodium plus 1, magnesium plus 2, aluminium plus 3. Oh my goodness. Number 3, size of metal ions. Very tricky. Yes, it is opposite. Why? Why is it opposite?
Atomic radius is smaller.
Atomic radius is smaller based on this, right? But indeed, once you know the concept of the attraction force, right? So you may get this is outermost shell and the nucleus. So whether or not the distance is just measured from the nucleus to the outermost shell. Okay, can you get my point? So while this distance is a reflection of attraction. So what do you know what's mean by that attraction? We call that nuclear attraction. Or another new term. So what is mean by nuclear attraction? Between nucleus is positive and electrons is negative. So they will put them together. They will have attraction together. Can you get my point? So can you tell, without using that data, can you tell how come sodium ions is greater in size than magnesium ion than aluminum ions? Without using that data, and you may also tell.
Because the melting point and boiling point of aluminium is higher than that of magnesium and sodium. So the nuclear attraction in aluminium ion is stronger.
After your reply, I know that this is confusing you. Okay? Yes?
其實H Group One and Group Seven 就係咪個 radius 係最大㗎嘛？即係大過中間嗰啲㗎嘛？係咪
？Reactivity 先係有。
No. You are just
Group 1 最大。
Yes, you are confusing those property. Okay, first of all, about atomic radius. Atomic radius across the period decrease. Okay, the elements, atomic radius of elements across the period decrease. From group 1 to group 7, group 0, they will drop. They will have a decreasing trend. And shall we take a look on the attraction force? What makes it positive in the nucleus? Let's try to put it this way. What makes it positive? It's because of something found in is positive. What is that?
Electrons, lost electrons.
Oh no. Nucleus. Take a look on nucleus. It is protons, okay? It's protons. How about the electrons? Of course, it is negative, right? So we are going to compare the number of protons and number of electrons by having sodium ion, magnesium, and aluminum ion now. Can you tell me the number of protons? According to periodic table, right? Atomic number, right? 11, 12, 13 protons, which is plus, okay? How about electrons? It's tricky this time. Which is?
Same number.
10,
Same
10,
number.
10.
Yes, it's just 10, 10, 10. So what will happen? Can you tell how come the aluminum ion is the smallest size when you compare with sodium ion?
They have a
Just
stronger nuclear attraction.
Yeah, there's a stronger nuclear attraction due to more number of protons inside. Can you get my point? So remember, that type of attraction can just occur inside the atom. Okay, remember, the nuclear attraction, they happen inside the atom. But if you want to talk about the metallic bond, it's different. Metallic bond is that we are now having the slope of between ion and the localized electron. So even though you talk about positive, negative, it's different. So which means that this so-called positive is Mg2+, including nucleus, and those non and also just those localized electrons. Can you get my point? So localized electrons, which means the inner shell electrons. So we have got that unit altogether. We've got Mg, but not nucleus. Can you get my point? So, and second, these electrons is not just orbiting around those ions. It is free moving, which means these electrons, they after 1 second, they will go to this or this direction, okay? They are freely moving. So remember, this is metallic bond. While this one is nuclear attraction, they are talking about two different concepts. Okay? And use this. So can you explain the difference in melting point of the three elements in the same period? Now, this is the take-home exercise, okay? Second question, explain the difference in the electrical conductivity of the three elements in the same period. Wow, Mr. Chin, what are you asking? Now, if you want to talk about melting point, I give you a hint, okay? Melting point, it is related, it is a type of physical property of a substance, okay? While this one, I would use what to explain? I will use bonding and structure to explain, as said before, right? So what is the difference between the bonding and structure between three elements in the same period? What does mean by the three elements? We've got sodium, magnesium, and aluminum. Oh no, Mr. Chin. That three, they are metals. So what bonding what are we talking about? Metallic bond. Not structure we are going to talk about. We call that giant metallic structure. Since we will know it, it will also form a 3D lattice, right? You may see that. Is it in form of 3D lattice? Of course, a giant structure. So if all three you talk about the same bonding structure, how come the melting point is different? The type of bonding, they are the same, but something is different, which is what? Yes, the strength of metallic bond is different. So this question will ask for what are the factors affecting the strength of metallic bond, which will make the melting point different. Okay, so once again, something about plus and minus. Can you get my point? Second, the difference in electrical conductivity. You need to again explain in the electrical conductivity in terms of its bonding and structure. Can you get my point? So bonding structure. So what bonding are we having? Metallic bond again. So what makes it electrically conductive? Is it about the particle inside? Which particle? That is
Electrons.
what electron?
Delocalized.
Yes, remember, not all electrons. So once you say that electrons, it is problematic. Not all electrons, they are said to be free moving, or we call that delocalized. So, and if you have got difference in electrical conductivity, which means that something about the localized electrons is different watts of the localized electrons will make it. You know its number, okay? So I leave these two for you to further investigate. Okay. Oh, but don't worry. I will post this question again. Okay. To the Google Classroom. Right. That question is from Form 3 final exam. Do you still find it? Do you still have it? Or go that way? Don't worry, huh? I will give it back to you and read it to study again. What do you think? I would just talk about ionic compound. I want to I just give you some templates of answering the question. And in the last 15 minutes, I will introduce one new concept about ionic structure, metallic structure, so metallic bond. So you may see this question in Form 3 again. So once you know more about this and you revisit again, you may find, well, it is something, a new world, right? A new understanding. So what I just mentioned in Form 3 final exam, it is metallic bond. Wow. Yes, that's right. So go home and please use it and answer that two questions while we meet. Today is Wednesday, right? Friday. We will see you guys Friday. Okay, is that clear? All right. See you guys. Bye-bye.
Bye bye.